Good morning, my YouTube viewers. Crystal here. What I wanted to do this morning was I wanted to do a comparison of two algorithms for analytics fajitas competition on the big Mart price predictions. Because even though I use XGBRegression on both of the algorithms to produce the price for that, but they gave slightly different results. Just not a huge difference, but a little bit of a difference. And whenever you're entering competitions, you want your result to be as good as possible. So what I'm going to do is I'm going to go over both files that I used to submit my submission to Analytics Vidhaya and show you what the difference was. The first one that I submitted was XGBoost, the file that says XGBoost. And this file, the results were just a tiny little bit, better than the other file, but the algorithm was much more simplistic. So what that tells you is sometimes a simple algorithm is going to work better than a complicated algorithm. And this particular algorithm, what I did was I used the model that I used for the Amy's house prices to predict the big Mart prices because it was a similar setup. And I want to go over that with you. So the first thing I did was I set up my libraries. I imported my libraries. And then I imported some more libraries because you never know exactly what you're going to need. And so I just imported a whole bunch of libraries just to be safe. And then what I did was I loaded my data set, so you can see the data set that I loaded. And so you can see all the different columns in this data set. I wanted to see the shape of the data set, so you can see it was 12 columns with 8523 rows. I wanted to see the information of the data set, so you could see you had several objects and floats. I wanted a description of the data set, so you could see the mean, the standard, the minimum, 25%, 50%, 75%, and the max, and also the count. And the next thing I did was I loaded my test data set. And the test data set had the same amount of columns, except for it didn't have the sales count column at the end, because that's what we were predicting. We were predicting the sales count. So I wanted to see the shape of the data set. So it was 5681 rows by 11 columns. And I wanted to see the information. Then I wanted a description of the data set, which contained similar information to the training data set. Then what I wanted to do was I wanted a description of the training outlet sales to see what was going on with that. And I had a graph, a displot of training outlet sales. And then what I had was I had a heat map of all the different variables going on with training outlet sales, so you can see how all of the characteristics had an impact on the ultimate sales. So I wanted to see the values. So I set up the Y value because you need to set up your Y value. And I combined the two files together, dropping the item outlet sales from the training column. And then I set up some coding to see where values were missing in the combined file. And then I had some information. I wanted information on the combined file. And what I did now was I filled one of the values with the mode, the outlet size with the mode, and I filled the item weight with the mean, because those were the two items that were missing values. The next thing I did was I checked the data frame to see if there were any zero values, and no, there were no more zero values. So I wanted to see a data frame, so I just did a df combine so you could see the data frame. Then I did get dummies, and so what that did was that converted categorical values into dummy values. And then you can see the df combine again. And so you can see the information on the get combine again. So now what we did was we set up the result, because you're going to need to have the result in order to carry out the prediction. And the result is combined dummies, because you had to get your gut dummies. And then we had to predict our sales price. So we set up values for X and Y. So I wanted to see how many dimensions were in X and how many dimensions were in Y. I just wanted to see that. So we had to create matrices for sklearn. So we created X and test values. So X was the training file and test values was the test file. Then we set up, we split the file into the training set and the testing set. And then now we use the XGBRegression algorithm and then we fit the algorithm and we made our predictions. And I just wanted to see what the length of YPRED was. And the length of YPRED was 2131. And that's because it had used the training file to test on. And so we printed our root mean squared. And what we did was now we showed a sample submission, because that's what Analytics Behavior wanted. That's the format they wanted. And so we set up our final labels. 1 equals clf.predict test values. And test values was your testing data frame. And then we changed any negative values to 0, because in Analytics Behavior, it won't accept any negative values. It'll crash the system. So that's what you have to do to change any negative values to 0. And I found that out the first time I submitted it. I wanted to see what the length of final labels 1 was, and it's 5681, and I wanted to see the length of final labels 2, and it was 5681. So I did the code, it's called the final result, to set up my submission file. And then I converted my submission file to a CSV file. And then so now you can see that this is your submission file here. And this is the submission file that I had submitted to Analytics Behavior. And it had a pretty good rating. I don't know. I mean, I got on the leaderboard. With this, and it had a pretty good rating. So that was the file where we used XGBRegression, and the file name had XGBoost on the end of it. So now what we're going to do is we're going to look at the file that says XGBRegression, and this file just scored just a little bit worse than the previous file that we looked at. So that's what I wanted to do. I wanted to compare these two algorithms. And the algorithm on this file is more complicated than the algorithm on the previous file that I showed you, which proves that just because something's complicated doesn't mean it's good. So I got the inspiration for this model from this web page right here because I don't want anyone to say that I'm plagiarizing any material. And what I did was I used the model, but I put the information for the big Mart files into it. It previously had the A&E's housing files. So just so you know where I got the inspiration to do this. So I loaded my data sets. You can see the data set. I wanted to see the shape of the data set, and I wanted to see information about the data set and a description of the data set. Then I loaded my test data set. So you can see the test data set. I wanted to see the shape of the test data set. I wanted information on the test data set, and I wanted a description of the test data set. And this coding here is a little bit different from the previous coding, but what they're doing is they want to see if there are any is-null characters, but instead of combining the two files, what they did was they just did the training file and the testing file separately, but it had basically the same information. So the outlet size had missing characters and item weight had missing characters. The outlet size is a text file and the item weight is a numeric file. Oh, we had a blank row there. I'll probably have to go through and delete that. And then what we did was we set up the train quantifier and the test quantifier. And what they did was they drop the item identifier. And the person who wrote this code originally, what he had done was he had done the code another way, but the only way that I could get this to work was to drop the code in the beginning. And it's not necessarily the coding that he had set it up, but it's the only way I could get this code to work. So you can see the train quantifier and the test quantifier where the item identifier has been dropped. And this is the code that that person used. And in the code that he used, he had dropped the item identifier in the code, but I could not get it to work with it dropped within the code. So I had to set up different coding to get it to work. And then so we imputed the data, and that was a little bit different format that was used in the previous file where he transformed the data. So this changes it from a data frame to an array, a NumPy array. And then what we did was after he did that, he converted it back to a data frame. Don't ask me why he did that, but he did it. And then what we did was we filled the missing values. Now, the missing values was outlet size. I did that as a mode, and the outlet weight, I wanted to do it as a median and then a mean, and I couldn't get it to work. And the only way that I could get it to work was to use the mode, but I thought, okay, well, just to get this file to work, we'll go ahead and use the mode. But what I really wanted was the mean for the item weight, or even the median, really. And we did that for the training file and the testing file. So what he did was he converted the file back into a data frame. And then we had a box plot, so you can see how we had a box plot and how these different values affected the price. We set up our Y value because you need to set up your Y value. So your Y value is train data imputed item outlet sales. And then we set up our distribution plot, and you can see where he set up the distribution plot so you can see these plots. So what we did was we created our X values. So we set up features. Features were item weight, item visibility, item MRP, and outlet establishment year. So I just took it that features were numeric, and we set up cat features was item fat content, item type, outlet identifier, outlet size, outlet location type, and outlet type, and I set that up as text files. And so all features equals features plus cat features. And then we set up our X value. X equals trained data imputed copy all features. And we split the file into two sets, one test training set and one testing set, which is the train test split mechanism. So we set up our text file. We did a one-hot encoding, and what one-hot encoding does is that sets categories up. Then he sets up his columns and his train predictors and his valuable predictors and one-hot predictors and one-hot test data. So now he's using the XGB regressor. And I will say that with XGB, if you're going to use XGBoost, then what you have to do is you have to set up the file in a different way, or XGBoost won't accept it. And I was looking at it for XGBoost, you have to set it up with like D matrix and stuff like that. I don't see any D matrix in this coding, and I didn't have any D matrix in the coding that I used. So that's what you're supposed to do. So he did his initial pass. So he set up his XGB regressor and he fit it. And then he made his predictions. He did some additional passes. He made some more predictions. And so he made his final predictions. And he printed this out. So what I did was I loaded the sample submission so you can see what Analytics Vidia wanted to see as an output. And so I set up my output, and the output was set up in the format that Analytics Vidia wanted to see. And I submitted that to Analytics Vidia, and I just got a slightly lower reading than I did on the previous file. And the previous file was the file that I used to set up housing prices. And I use that. So that just goes to show you that the more complicated algorithms are not necessarily the best algorithms. And from what I've read and studied and watched YouTube videos on the subject, is you're supposed to keep your algorithms as simple as possible. And this algorithm I'm showing you is a good algorithm. It was a good algorithm for the house prices. I got a better algorithm for the house prices than I did on the lasso command. So it is a good algorithm, but it's more complicated than the previous algorithm. So that means that you always have to test your algorithm, see which algorithm is going to give you the best score. So I suppose that completes this presentation on a comparison of the two different algorithms for the house, for the big Mart sales, because this is big Mart sales. And if you like my video, please like, subscribe, and share. If you like the work that I do, if you want to make a donation, I've got my email address down below, so you can put a donation in my PayPal account, which will be very gratefully received to defray the cost of my living expenses. And thank you so much for watching this video, and I look forward to you watching the next one.